we're going to show you the rapid method of adding numbers. Now, strategy we adopt here is how to handle carry. Addition, the carry is a major part. It's confused student, or it's become a problem when you do mental calculation. It's like with a paper and pencil you calculate, then carry complicate matter. For example, let's look at the example here. What we do is usually 6 plus 8, then you get 4. Let me change the color. Now we add the carry 1, so become 9. Okay, then 5. Now in order to speed up, what we do is we ignore this carry. Okay, just add this number, just forget about over 10. It's gonna be 4, 8, 5. Okay, the answer is wrong because this produce carry. So what you do is you get this quick, then look up and see if there is a carry, then you add this, and that's what you do mentally, so that you don't have to deal with this kind of things. Okay, now the problem is it's complicated very occasionally when carry propagate. Propagate means I show you the example. In this case, 8, 2 is 0, and 1, this becomes 0. Then another 1 goes up, then it's become 5, right? Now, if we use our method, ignore the carry. So 0, 9, 4, right? And you look at, see where it's generated carry. Okay, so we add 1 here, 5, 0, 0. So this is kind of mental process. It's long process, but this is rare. Why you spend you prepare you spend a lot of time preparing for something. It's rarely happen. You're not in the insurance company business. So what we do is just ignore any carry, just add it directly. We call that adding method half adder. Okay, for example, this one is 9, 9, 5. That's it. In this case, no carry. It's very quick. It's 4, 7, 7. Don't worry about carry, right? So that's the strategy we adopt overall in this section. Okay, hope you pick up something useful. Let's start.
Adding large numbers. When you get your receipt at the cash register, usually you would check to see if the sum is correct, wouldn't you? Especially if it seems as if the items you purchased for the total just simply don't add up. The rapid adding method will be very handy in this situation. Let's talk about why they teach carrying and borrowing for addition and subtraction in school. These are necessary to get a correct answer for any combination of numbers. But there is a quicker way to handle carries and borrows for most cases. What you learned in school is the way it works for any given situation. The rapid method you learn here is not what they teach in school, but a derivative from the method used in scientific computers and is a much quicker way to add or subtract numbers. Using this derivative method, you can get an answer much quicker most of the time. Occasionally, you may encounter a situation where you need more time to get the answer. If you do, just use the method you learned in school. But 95% of the time, you can calculate addition and subtraction using the rapid number crunching method without paper and pencil. You do not need to worry about this 5% of the time in the real world where you may need to use a pencil and paper to get the precise answer. Let's look at the first addition example. We utilize the so-called half adder from a computer's brain. Basically, you add two numbers, such as 5 and 7, and take only the first digit, 2, as the answer. The carry is completely ignored. We need to get used to doing this quick in order to perform the rapid addition method. In the example, you'll see the half-adder result for two large numbers. We have also carry look ahead as indicated by the character y. When we perform addition by the rapid method, we add from left to right the highest digit to lower digit. This is important in real life. Taking care of large figures first, worrying about the small portion later. When you calculate money, this is the way to go. We simply perform the half-adder from the top. In this example, 2 plus 4 equals 6. But the first digit is 7 because the next digit is marked by the character y. This y is the carry lookup. After the half-adder is performed, the value is adjusted by 1 depending on whether there is a y at the next digit or not. If there is y at the next digit, the carry lookup is y, and then we add 1 to the result of the half-adder. Moving on to the next digit, the half-adder result is 1, and there is no additional 1 to be adjusted because the carry lookup shows no y marking. Keep moving to the right, the half-adder result is 6 plus 1 for the carry lookup y mark at the next digit. You should see the next digit as being 2 plus 1 for carry lookup, and the next digit 1 without any adjustment for the carry lookup at all. The last half-adder is 7. There will never be a carry lookup for the last digit. Now we are going to do this all by heart without paper and pencil. Let's look at the first question. The higher digit produces 7 plus 1 from carry look ahead, so the first digit is 8. The next digit is 5 plus 8 equals 3, and there is no adjustment to the value, so the second digit is 3. The next digit is 2 plus 6 equals 8, but carry lookup adjustment is needed, so the answer is 9. The next digit is 7 plus 5 equals 2, and carry lookup adjustment is needed as the answer is 3. The last digit is 8 plus 4 equals 2. Therefore, the answer, 83,932. In the second practice, we'll go faster. The first digit is 11. The top digit may have carryover, and that'll make the answer 2 digits. The second digit is 4. Next digit is 3. The next digit is 3. And the last digit is 5. The answer, therefore, is 114,335. Are you ready to go faster for the third question? The first top digit is 8. The second is 9. The third is 1, the fourth is 2, and the last one is 6, making the answer 89,126. It's a very fast and easy way to add two large numbers. I must be honest with you about the selection of examples that you've just used are trouble-free addition for you so far. I'll give you a case where a simple lookup that we have used here does not work. The problem that you face here is that you have 9 when you add two numbers toward the end, one before last digit, 0 plus 9. When you have 9, you ignore the carry bit. This is the rule by the half-adder. Then you have an incorrect answer until you go through the carry steps. You need the delayed carry stage to add the propagating carry to get the correct answer. Why is this called propagating carry? Because you do not know if the half-adder result 9 will turn into 10 until you look up the lower digit adder result. If that is 9 again, you need to go one more step down to see if there is any carry coming. This is the basic adder problem in computer design, and any computer looks up all the way very quickly to obtain the correct answer. The method you learned in school, adding from the right side, also gives you a correct answer. Now you know why they teach you to add from the right side, because it is the least significant digit. You need to take care of this propagating carry from right to left. Our rapid method uses only a simple carry lookup, meaning we'll only be looking at the next digit to see if there is a carry. Therefore, it will give a wrong answer sometimes unless you apply the delayed carry. In most practical cases of life, do we really need to get the exact, correct answer all the time? Remember, you'll be doing this without pen and paper. The objective is to get an accurate answer as quickly as possible. When speed is more important than accuracy, you use the rapid method. If you feel that a simple carry lookup is good enough for your situation, you can ignore the delayed carry. The delayed carry is used to correct the answer, and it takes additional time to do. When you need more accuracy, delayed carry will provide the correct answer with the amount of extra time you spend. The rapid method deals with cases in real life. In many circumstances, you do not encounter propagating carry that often. You get the correct answer by just a half adder with a simple carry look-ahead. But when you know many 9s are produced by a half adder, you need to check the answer. Without paper and pencil, this can be a little more difficult for a large number, but let's try to understand what's really going on here. If there is a Y character next to any 9, this 9 needs to be turned into 0, and the upper digit gets carried. This means the carry propagates through the number 9. This propagation may be a long pipe depending on the kind of addition you need to perform. For the example on the screen, you see by the character Y at the lower digit and the carry propagating through 2 9s, the carry lands on 8. As the result, 8 becomes 9. On the other hand, we had 9 at the second digit from the top by adding 7 and 2. But there is no Y, so 9 stays as 9. This is a method referred to as 9 compensation. The rapid method ignores this propagating carry. It produces an approximate answer, but the error is not large since the amount that is propagating is from the far right side. In real life, it will be the fuzzy amount included in the tips you give out. This delayed carry costs more time to perform an addition. The fact is that you do not need to do it most of the time in real life. Therefore, still using the half adder method gives you not only speed, but an edge. Let's tackle some practice problems. When you look at the first question, you start with 3 plus 3 equals 6, but add 1 because the next digit generates a carry, so the answer is 7. The next is 7, the next digit is 9, and the last one is 0. The answer is 7,790. Now it's time for the 9 compensation. After compensating 9, the final answer is 7,800. Can you do this just by looking at the question? Remember, no pencil and paper. The next question starts with 6, then 9, then 1, then 6, then 4. We have 9, and the next digit of 9 generates a carry, so we perform the 9 compensation again to get the final answer of 60,164. The last question starts with 5, 8, 9, 1, and 0. The 9 compensation changes the final answer to 59,010. This method is based on the quick calculations of the half adder. Let's review this. Add 2 single-digit numbers and ignore the carry-out, but check the carry from the lower side. Exception: leave 9 alone. Don't carry it in. 9 will be compensated later if necessary. Next, we'll practice how to add multiple numbers together. You have purchased 5 items, and you want to know the total. Most people add the first 2 items and add the price of the third item to the sum of the first 2 items. Then, they continue adding the fourth price and so on. This means that you need to perform addition 4 times. Having a list of items and prices on a small piece of paper receipt, you can add the highest digit of all items and move down to the right. It's much faster to add them in this method and possible to do it without a pen or calculator. We number from the highest digit as column 1, 2, 3, and 4. The first step is to do the half adder on each column, but without checking the carry from the lower digit. This means all carries will be ignored. You easily get 20.81. During this process, you can change the order of numbers to add so that you can perform the half adder faster. In column 1, you look at 4, 1, 3, and 2, which make 10, so ignore them all and get 2. In column 2, 5 and 6 makes 11, so it reduces to 1 and 3's make 9, so the total will be 0. In column 3, 3 4's make 12. Give 1 to 9 to eliminate it, so you have only 1, and then add 7 to the remaining 1 to get 8. In column 4, we have 2 5's that will be eliminated. 2 8's make 16, together with the last 5, and the remaining number is only 1. There is no 9 in the answer, so do not worry about the 9 compensation. Now we need to put all the carries together. We make the carry-only number as follows. In the first column, you check to see how many carryouts will be generated. 2, 3, 1, 4, and 2 make only 1 carry, so 1 is the first number of the answer. The second column will generate 2 carries. The third column generates 2, and the last column generates 3. Therefore, carries make the number 122.3, and when you add it to 20.81, you get the final answer. Use the same rapid methods to add them all again. An important point to remember here is that multiple number additions are reduced into half-adder results and carries using the rapid addition method we learned previously. How can we do all of this without a paper and pencil? We'll show you an easier way to do this in the following section. However, remember this process, because this method gives a correct answer and you can always use it when you have no pencil and paper. Let's simplify the process so that you can do this type of addition by just looking at the multiple numbers. We used y characters as a carry for two-number addition. Instead of y, you get a number like 1, 2, 3, etc. in the multiple number addition. In order to perform the multi-number addition without using pencil and paper, we need to add carries to the half-adder result directly. We'll explain this process in detail. In column 1, check the carryout first. You get 1, and this is the first digit of the final answer. In column 2, you check the carryout and you get 2. You perform the half-adder on column 1 and get 2, so you need to add 2 and 2 and obtain 4. This is the second digit of the final answer. Moving on to the third column, check the carry and get 2, and perform the half-adder in column 2 and get 0, so the final third digit of the final answer is 2. You repeat this process until you're finished with all columns. This method is the same as the first method you learned for two-number additions, except the character y is changed into the carry number. So when you get y, do you perform the 9 compensation? The propagation amount increases when you add more numbers, carries produce more propagation, and then more for even less numbers such as 8, 7, 6, etc. When you encounter a longer propagation, then you need to go back to the previous method, reducing multiple additions into two-number additions. For daily use in real life, the rapid method described here works very well. Let's do some practice. With this first question, look at the first column to see if any carries exist. None do. The next column has a carry of 1. The half-adder of the first column produces 7, so the first digit is 8. The third column produces carry 1, and the second column half-adder produces 1, so the second digit is 2. The fourth column produces 1 carry and third column half-adder produces 7, so the third digit is 8. The last column half-adder produces 8. Thus, the final answer is 82.88. The next question in the practice starts with the first column producing no carry. Second column produces 1 carry, and half adder of first column produces 6, so 7 is the first digit. Third column produces no carry, and second column half adder produces 1, so the second digit is 1. Fourth column product is 1 carry, and half adder of the third column produces 2, so it's 3. The last column's half adder produces 3, so the last digit is 3. Therefore, the answer is 71.33. Let's go faster on this last question. Carry is 1. Carry from second column plus 0 is 1. Carry from third column is none, so 0. Carry from fourth column is 1, and half adder of third column is 7, so 8. Carry from last column is 1, and half adder of fourth column is 1, so 2. Finally, half adder of last column produces 2. Therefore, the answer is 1108.22. 95% of the cases you'll encounter in daily life, this method will work well. You may run into long carry propagation occasionally, but you'll just need a pencil and paper to do it using the reducing to 2-number adding method only if you need an accurate answer. The delayed carry method here is still much faster than the traditional method you were taught in school.
So we have explained in very details that how this half adder and the carry strategy works. Let's try this again. The same questions we show in the beginning. We have shown this already once. Now after you learn how to do it, let's do it again for the review. Okay, 2 plus 3 is 5. There's nothing from there, so it's a 5. And this is going to be 8, but there seems to be a carry, so you said 9 and 2, right? Now this one, it's 4, but next one is 9, so there is a potentially carry over from others. See, 8, 2 is going to produce carry. Then it's going to be carry again. So this is a rare case. It doesn't happen. It's rarely happen, so we don't have to worry about this. Now this one's 5 and 9, 9. So 7, 7, 4. So you can do from left to right. All the addition and subtraction in the rapid method we do left to right. Okay, so by looking at this number, you get answer right away. That's the deal. Now you can do this even without looking at this. If you can retain about 6 figures, that's need a little bit practice. Okay, but you can do that. A lot of people have a problem retaining numbers like more than 5. So 2, 3, 4 plus 24. Most of people can do this. So from top, no problem. There's no even carry. 4, 6, 7, and 45. So in this case, what you do is you have a carry, so 5, 0, right? And this is gonna be carry, so just rewrite here 5, 12. So that can be done without even looking at the numbers on the paper, right? So that's the method to speed up the calculation. Actually, in computer, it all kinds of different methods tried to add the numbers, and the way you learn in school, writing carry over here, is the most inefficient way, but it produces correct result all the time for any kind of addition. And that's the key point of teaching that way in the school. But in reality, in the daily life, you don't need that. You just go from larger number from left to right. Okay, I hope this helps. We have subtraction and also multiplication, rapid multiplication and divisions, and some business math video. Please check it out. Thank you.